Everyone. Let me just share my screen. It's a real pleasure to be here today and to be talking about one of my favorite topics. I never get asked to talk about it. I get always asked to talk about recruiting, but I think it is something that I think about, I read a lot about, and I hope that passion sort of translates into like a huge amount of energy for you guys. And so I'm going to be focusing so that Reese can actually come back and give his version of algorithmic responsibility. I really wanted to focus on some of the sort of recent work that we've been doing and others have been doing about biases in recruiting. And I think these have important implications in terms of the rest of the processes and the decisions that we make in talent management. And I think it's a really interesting sort of viewpoint of all of this. But before I start, I wanted to sort of talk a little bit, not about things that decide what we read or what we eat, but some of the really impressive ways in which AI has really developed. And so on the left here is an example of GPT-2, which is a model that used billions and billions and billions of written text to understand English language. And so you put in a prompt, and you can see when you start off with a prompt, it then generates a whole essay around that prompt. And it does so in a way that you can sort of see that looks pretty normal. It looks pretty, it doesn't look too crazy like old models used to do. And so it's becoming very readable. It's actually there's a beautiful article written in the New Yorker, I think, that was talking about how this writer was sort of struggling with it because it was getting to know things and writing things in empathetic ways compared to what he wanted to write. And so it's a really interesting sort of time to be looking at prediction machines and algorithms. And I think on the right-hand side, what I'm going to show you is, and I'm not sure if that went up, but this is an example of, and I'm going to turn the volume down, of Barack Obama, the way that you've been able to mish and mash a video with a picture and to give a new identity or a new role to someone. And these are called deep fakes, and they're being used in a lot of different ways. What's very scary about them in terms of the effect on democracy is in which you have leaders making pronouncements in very obviously in videos that it's very difficult to tell are sort of made up, that can have sort of dramatic impacts in terms of how people react to them. And so this new sort of algorithms and the amount of data that goes into these are now sort of blurring the line of what is real. And they're sort of creating predictions that, sort of have like are leaving us sort of in the analog world in some senses. So, I mean, I'm glad I'm not a history teacher, but I don't look forward to reading essays written by these machines. But, we now need to build systems to address, the complexity and the lack of realness in some of these systems and trying to figure out what's real and what's not real. So by way of context, I guess one of the primary examples of when these algorithms have been used in a very personalizable way, which to my heart sort of is very deeply problematic, is when ads have restricted opportunities for housing, employment, or credit, as they have in this historic case that I think the ACLU took to Facebook. And essentially, the ability to personalize things to such a level and boil it down to excluding specific groups and protected characteristics is a real problematic area. And this is an area that we're sort of coming into in terms of the amount of data that these algorithms have about us and the way in which this decision making can be very much abstracted and automated. And so it's hard to tell whose fault it was that these sorts of issues develop. Like in part, when you fund an ad platform, you're incentivizing certain behaviors, and this is a slippery slope that we're sort of at the precipice of in some senses. And so to take a step back, and before we go into a lot of algorithms and a lot of AI, I wanted to talk a little bit about just some of the terms that I'm going to be mentioning, and I'm going to refer to algorithms very broadly today. So they can be as simple as an if statement, and many of my students certainly have used these in their statistics course, is to make decisions about things based on certain cutoffs. And these are algorithms that we've been using since the 1950s, definitely in economics, we've been building them. On the other extreme of the scale, And these are things that we see much more right now. These are probably what you think of most commonly in terms of prediction algorithms, is a little bit different in terms of its relationship to the rules. So in machine learning or artificial intelligence, you basically give it a bunch of data and you give it a bunch of labels and you tell the machine, figure out what that rule is. And it does that through a range of testing, and it's trying to get the most accurate result. And then we develop this algorithm. And then what happens then is, in the case of, for example, various, for example, your Netflix queue or whatever else, it's already learned that, a person who likes this will probably like this other thing. And so if it knows that I like, for example, panda bears, it will then decide to give me more panda related content, or it might give me something adjacent like, grizzly bears or various other things. But it's using that input data that I like one thing to infer that I might like another thing, or that, it should serve up this information to me. And we know that these things are developing rules in their sort of process. So they're using that data to extract what it thinks its rules are. And those rules can be both, depending on the algorithm, they can either be open box or closed box. And so this is sort of summarizes a lot of different ideas that I want to talk a little bit about today before I get into recruiting. And I want you to keep in the back of your mind, because many of you may not be going ahead and implementing these algorithms necessarily, but you will be talking to vendors who have implemented them. And I think it's really important to understand, to sort of push them a little bit, especially because in HR, a lot of these tools, especially, I'm coming from a software company that is a HR tech company, but these tools are things that are based on various types of data, and that you need to be informed as a consumer, both in terms of your own personal life and the data that you carry with you, as well as the ones of your employees. So this sort of automated decision-making can vary in terms of its complexity. And there are a few different tensions. So one tension that is very common and that I want you to take away from today is this idea of accuracy versus interpretability. And so you have what we call white box models, which are transparent. So it means that we know what goes in and why it comes out. And regression models are a perfect example of that, but there are things like decision trees. Many of you would be familiar with how you make like if-else statement decision trees in, for example, your Excel spreadsheets. On the other end of the spectrum are things like black box models. These tend to be opaque. They can be multiple models stacked on top of each other. And so it's going to be very good at getting what we call like accuracy. It can be very exact, but it also comes with, it means that we can't see what went into that model. And these are things that are commonly called neural networks. Their gradient boosting is another sort of form of a model, and ensemble models are many, many different models stacked on top of each other. So the problem here is that, we have these two extremities. We have accuracy versus interpretability at the two ends. And one of the recent things that has definitely become very critical recently is that we've had these development of model interpretability algorithms. And essentially what these do is that they sit on top of a black box model, and then they try and test, if I change the gender of this person, what's the result of this, this credit algorithm? If I change the race of this person, what's the result? And so what they try and do is approximate what they think is going on in those models. And some examples of these, and I don't want to go into a lot of detail, but I do want to mention this, that this can sit on top of a black box model to give us interpretability. But they're things like Lyman Sharp. They're not exactly right. They're going to sort of somewhat get there. And I wanted to highlight that these exist because I think I'm going to talk a little bit about them.
Maryam?
So to go back to the central topic that I wanted to talk about today, it was about algorithms and AI in recruiting. And many of you would be probably a little familiar or have heard this example of Amazon, but I wanted to remind you because it's been a couple of years now. So about a number of years ago, maybe I think it was about 5 years ago, Amazon started developing a tool that is supposed to, an algorithm that was supposed to help them identify who are good potential candidates. And they did this using machine learning models, and they were trying to understand what features do the people who were eventually hired by Amazon have that the people who aren't hired by Amazon don't have. And so their idea was to try and understand, what makes a successful candidate, and so that they could sort of streamline their processes. And they used 10 years of hiring data. And I think this specific, this article, which is a wonderful article actually, it was the investigative reporting that was done by Reuters over a number of years, it sort of highlights that, this tool ended up showing bias against women. And so this was a black box tool, which basically went through and looked at candidate resumes and sorted them into those who were hired and those who weren't hired. And it got trained on this. And then, you know, when it came to this, it started looking at test resumes, and we put in a level of machine learning interpretability algorithms. And what people found was that this was discriminating against women. And why would Amazon do this? It sounds like a crazy thing to do when you think of it from from the end point. But the reality is, and this is a fundamental problem that we have, is that resume screening in recruiting is incredibly bias prone. And we know this from, this is just a subset of the examples of specific instances where we've seen big differences in terms of how many people receive, who proceed to each stage based on their demographics. These are examples of specifically audit studies, which are actually used by the EEOC now to determine instances where we've seen different levels of callbacks from demographics and to sort of take them to court. And so these are, I think this is a very bias prone process when humans are making decisions. It's also a very slow process, and it's also an expensive process. And the expense of this process varies. I know SHRM says has an average of $4,000. When you count people's time and effort that it goes into it, you can, depending on which technologies people use and how thorough their review process is, it can explode back up for each candidate. It's an expensive process. And it's a slow process. So, our average time to fill from internal sort of numbers that we have is reasonably long. It takes 2 months, frequently longer for more senior roles and less for less senior roles. So it's a problematic process. It's not efficient in any way. And so it makes sense to address this through, a mechanism that might speed it up. And I think this is sort of reflects, I'm going to keep using tweets as an example because I think it is a wonderfully sort of way to get a view into people's sociology and the sort of major thinkfluences in our time in terms of what they think about these processes. But this journalist, Ryan Broderick, was talking about sort of summarize what it was. And essentially these when we apply an interpretability algorithm to Amazon's machine learning system, what they found was that there were penalizing resumes that included the word women's, people who came from women's colleges were highly downgraded. And he was upgrading what he describes as aggressive language, but verbs. It wasn't upvoting things like software or the sort of technologies that people use, but it was using certain cues in the language, which we know, from various studies that we've done, men and women write resumes very differently. And so that probably it was catching on to the fact that there are differences in that language. And I think the other thing that this highlights, and this is an important point, is that these systems are a reflection of the data that's put into them, and they can be amazing for identifying causes of instances of bias. I'm not sure that they're so wonderful for overcoming some of those biases. And Amazon tried actually very hard over the course of many years to try and limit the amount of bias that was happening in those models. But one part of it is that, when you have data that primarily hires men or male engineers, and it's very difficult to overcome that. So
Maryam,
with all of that, I think one of the important questions.
Maryam, can you hear me?
Yes.
When would be the appropriate time to ask questions? We have a couple of questions from there. Okay.
Oh yeah, of course.
So one came from Eric, and he is asking how, because there is a different terminology, right? Deterministic versus probabilistic terms that are being used. So how do those map to some of the terms like the white versus opaque model?
Oh, okay. So a white box model or a sort of open box model is probably more associated with statistical models, and certainly depending on whether it doesn't matter if it's frequentist or not, but they tend to be more statistical side of things. versus what are conventionally machine learning on the black box side of things, which can be quite diffuse in terms of the reasoning. Like you can have lots of different neurons like working in a certain way to make a decision, and you don't really understand what are the signals into those neurons necessarily.
Great. Then there is another one from Adrian, curious about consensus around interpretability in general, with various visualization techniques such as attention vectors classified as interpretable outputs.
Yeah, so I think there's to put it in context for everyone, there's been a lot of work done in terms of trying to identify, for example, especially in computer vision, what are the pixels that contributed to you thinking that this picture is a cat and not a dog? And there's similar sorts of work that's been done in terms of language, which is also very high dimensional in terms of the thought process in terms of identifying what contributes to what. And certainly that was something that was done in the Amazon case in terms of visualization. One of my issues with those interpretable algorithms, and I think it's important that they flag up problems that you might see and what's causing the root of those problems. Like we wouldn't know without those algorithms what was causing the number of women to not be accepted by Amazon. We are able to do that now, and that's very important. But how that feeds back into developing a responsible model is not yet like something that I think we can address very well. Bias reduction algorithms have been generated. Certainly, I work in natural language processing a lot, and bias is a problem in a lot of different areas. And this is not just a bias against gender or bias against a certain subgroup, but it's also the things that we choose to write about and the things that we choose to collect historically have been certain types of stories or certain types of writing. And there's a lot that's not in there. And so when these algorithms encounter things that aren't part of that corpus, it has a very difficult time characterizing those. And so I'll talk a little bit more about that later when I talk about COVID specifically. But what I would say there is that those bias reduction algorithms, for example, if we think about it in terms of gender, only work in one dimension. You can reduce the bias of an algorithm, for example, in terms of gender, but you can't then reduce the bias in terms of race. And we know that these biases interact in weird and unusual ways, and it's quite difficult to deal with that in these algorithms. And so that's why I'm sort of on the board of trying to take the hit in terms of accuracy and towards understanding what we're seeing, because I think some of the complexities, the thing that I didn't mention is that in terms of black box algorithms, one of the reasons why they're very effective or have a very high accuracy rate is that they can overfit. And what I mean by that is it's like learning components that aren't really critical to the understanding. So it's learning patterns that might not exactly explain something. And I think that's definitely been the case in the language models. So they learn by understanding the way in which you highlight things, or the way in which some of the broader context that might not actually matter in terms of what you're trying to say. And so there is that recurrent problem. And I think that that's still an open question, but I choose to, as someone who works in the area where access to opportunity is really important, I need to have it be as open box as possible. And so that's where I lie on that question. It means that there's a lot of tools that we don't necessarily use as much as we'd like to, but there's issues in terms of long-term viability there.
And this probably is something you may touch later on, so
Yep.
You don't have to touch, but just put it in your head to discuss LinkedIn algorithms and how they make decisions and what that looks like.
Oh, I finally I knew. No, that's I think those are interesting questions. I know LinkedIn recently gave a talk actually about, and actually I'm going to talk a bit about that in a couple of slides specifically, so I'll come back to that. So